Hi, this is Chris, the guitar amp tech from Sydney, Australia. You know, I've always had a huge respect for German quality, whether it's a Mercedes or my GTI Golf or my Duesenberg guitar. Their attention to detail is immaculate. Over 20 years ago, these two German guys, Peter Stapfer and Peter Deizel, started Deizel amplification in a town about 3 hours east of Frankfurt, where I have been lucky enough to go several times in my past life as a process engineer. Guten Tag, Stefan und Ulrich. I haven't worked on a Deizel before, and that's because they're quite expensive in Australia, and they are very well made, German well made, so they don't fail. This job should be pretty straightforward. The owner wants it converted from USA voltages to Australian voltages. I don't have a schematic, but we will see if we can figure it out without one. We will also have a look over the amplifier as a whole, which should be a bit of fun. I might even play through it with my Duesenberg, of course. If this sounds of interest to you, go grab a coffee, pull up a chair, sit beside me, and let's start pulling this baby apart. Well, regardless of whether you like high gain amps or not, you gotta admit, this thing is beautiful. This is metal, and all of this intricate cut out bits of metal, just beautiful. And I really like the way they've done this. So it's channel 1 and channel 2 with the one bar between them. So from a distance, that actually looks like it's a slider. But it's actually, you know, gain, channel 1, channel 2, volume, etc., etc., etc. Beautiful. Selector, I guess that's to go between channel 1 and 2. There's also a foot switch, which will go between 1 and 2. There's a master. This master here doesn't have that LED, which this one does. Not sure what's happening here. Here's the foot switch. So I'm gathering that the foot switch obviously changes the channels. And this master, I'm not sure what that selection does. Does it turn the master on and off? Does it bypass the master? Yeah, I'm not sure. But we might find that out as we go. Let's have a look at the back. Okay, this is interesting. The power showing that 230 is indicated, but the owner said it's selected to American, which should be 120. So I'm just going to check it anyway, and we'll figure out what are the appropriate windings to go to 240. This is good. So this is telling me that there's going to be at least 100, 120. So there's going to be 4 taps per primary wind, and when I get onto a bit of paper, I'll show you what I mean by that. A little drawer there for the fuse. We've got to make sure that that fuse is going to be selected, installed with a 2 amp slow blow when we do the change. Serial send return loop. As we've discovered in other repairs, it's critical that these contacts are kept scrupulously clean, or else it's a potential problem area. Foot switch, I'm assuming that's this fella that we saw before. And wow, what a selection of speaker outs. Pretty much any combination you can think of, a 16, 2 16s, or a single 8, 2 16s in parallel, I mean. A single 4 or 2 8s in parallel. Excellent, I like that. All right, we got that same cutout here again. That's beautiful, I love the way that's been done. Okay, let's open it up and see what's inside. If an indicator of a well-made cabinet is how it's finished on the inside, then this is brilliant. I've got a huge, solid bit of shielding down on the bottom edge, which is where the circuit board's exposed. Beautifully no loose flaps of vinyl, except for one bit here, which I'd say was when the amp chassis was pushed into place. I'll glue that back down so that it's in keeping with the rest of it. Beautiful. Here's the top of the chassis. All of the preamp tubes have got shields on them. All of the power tubes, the 4EL34s, have got claws on them. Even though this amp is sitting upright, unlike Fenders, they've still secured them with claws. I like that. Now you'll see, that looks like it's probably the choke for the power supply. We know this is the power transformer. One really easy clue is to look at the back, and the power transformer is nearly always going to be where your power cord comes in. Now here's a little thing that, and the output transformer you'll notice is at the opposite end of the chassis. And have you noticed something about them? See how this one is standing up with the bell covers this way. At the opposite side, this one's effectively lying down with the bell covers on the top and on the bottom. 90 degrees apart from the power transformer. Why is that important? Let me just do you a quick sketch. I'm not going to do a long, boring explanation of how a transformer works, but primary comes in here and it is wound around this iron core. The iron core transmits or passes the magnetic flux from the primary to the secondary. There is no electrical connection between the primary and the secondary. And if there's no earth passed through from the primary to the secondary, then this is called an isolation transformer. There is no electrical connection between the secondary and the primary. It's just transmitted by the magnetic flux. And to stop the magnetic flux going all crazy and flapping all over the place, they laminate many, many layers of conductive metal, typically iron, and in a perfect world, all of the magnetic flux, 100% of the magnetic flux, would go from this primary induced thing through those laminations, stopping those crazy eddy currents. Oops, front door. So flux is pretty dumb. It doesn't know that it's got to go from the primary to the secondary. It's just following the easiest path that it can, and it happens to be going around and around the core of the transformer. And if the transformer was 100% efficient, there would be no eddy currents in here. There would be no flux leakage, which is what our concern is. It'd just go 100% transfer of magnetic energy from there to there, and would have really efficient transformers. I'm not sure what the figure is. As it is, it's pretty efficient. Let's say it's 90-95% efficient. Don't know that figure, I just made it up. Problem is this flux leakage, right? It's going and around in this plane. So there's going to be a bit of leakage. And if there is another transformer, for example, let's call it the output transformer as an example, and it happens to be set up in the same orientation as this, and forget the electrical wires, but let's just say it had a core here like this, and there were windings in the same direction as that. That flux would leak into the other transformer, and now we're going to have a problem. Because what's the frequency of this? It's not the frequency of our guitar. It's the frequency of our mains. Here it's 50 hertz, in America it's 60 hertz. So we're now going to have a 60 hertz hum induced into the secondary of our output transformer. So how do we minimize that? Well, we do exactly what Deizel have done. We lay the second transformer down and around. So you do everything you can to make sure that this magnetic field will not induce a current in the other magnetic field. And then the other thing you can do is separate them as far as you can. And if you look at the Deizel, you'll see they have done exactly that. Power transformer, choke, both of which have just got 50 hertz on them, on the opposite ends of a long chassis to the output transformer. Well, here's a look at the inside of the chassis. Nice, good quality circuit board. All of the tubes are mounted to the chassis. Nothing is, you can move the tubes around. Nothing's moving on the PCB. So we see on cheaper amps that you can get cracking of the solder bases from movement. Nice big filter capacitors, huge 1N508 diodes. They're never going to blow. What else? High current diodes here, rather rectifier. I don't know about these pots that they've chosen to use. Look, I'm just old school. These are Alpha pots, good brand, small body, metal body at least. They're not the cheapo plastic ones we see on Marshalls and Blues Juniors and stuff. I guess I'd still like to see the larger pots that we see on, the vintage Fenders, but hey, these guys have done their research. Here is our wiring for our power transformer, and we're going to have to decipher what wire is what. So I'll show you how we're going to do this. A lot of primaries that are going to equipment which has got an international market will have their primary coil in two parts, and there will be, like this amp has, there's sub taps in there. But let's just take the easy example, and we're going to say that's 0, 120, 120, 0. So if we wanted to wire this for 120 volts, we would connect this wire to here, and we'd connect this wire to here, and we've got those two coils in parallel, so it'll be 120 volts on the input side and the same on the outside. Now, if we want to run this in Australia, where we're going to have the two 120 volt coils, then we're going to put them in series. So we'll connect that to there, and then that becomes our 0 volt, and that becomes 240 volt. So now we've got to try and crack their color coding and how to do this, because there's going to be taps here for 230 volts, which will be, there'll be a 115 volt tap here, and there we go, this is a bit of a clue, 100 volt tap. So there'll be 100 volts here as well. So we're going to have 0 volt, 100 volt tap, 115 volt tap, and 120 volt tap. And how we wire these in series or parallel will define what voltage we get as our primary. If we don't have a color code for this, then one way we can crack the code is to measure the DC resistance, because it's easy to do. We just get an accurate meter. It's going to be very low impedances, probably less than 3 ohms I'd expect. That's going to be between here and here. And this is going to be, I'm going to pick a value, right? This is going to be like 1 ohm. This is going to be a little bit bigger, 115, say 1.5. And this is going to be a little bit bigger, let's say 2, something like that. 2 ohms of DC resistance. It's not going to give us enough accuracy to do turns ratio and all that sort of stuff. All we want to do is identify which colours are going to be which taps, and there will be 2 coils on the primary, so we can series them and parallel them. Okay, this is a little bit slow. I'm going to do this using probably the most accurate meter I've got here. I've got some pretty good meters, but probably I trust the Fluke more than anything else. I don't need to set it to high res, single digit decimal point is probably going to be good enough, but we'll see. Okay, this is what I've figured out. It took me a little bit of a while to get all these measurements and figure out what the colours represented and what the commons were. But here's our two coils. So black is 0, 1.3 ohms above that is the brown, and our lowest voltage option is 100 volts, so that would be the 100 volt tap. Then 1.6 ohms above 0, we've got another tap, which we're going to take as being 115, that's red. And then 1.7 ohms above 0 is violet, and that's 120 volts. Same with the second, the other winding, we've got yellow, green is 100 volts, blue is 115, and grey is 120. So I don't think this amp was actually wired for 120 volts. I'm thinking it was wired for 230 volts, which is what is marked on the back of the amp, and it's what I'm seeing here. Because for 230 volts, we're going to be wanting two 115 volt winds. So what we are indeed seeing is this blue wire, black wire, tied to the blue wire, which gives us 115 volts on each wind. So then if we take it between, to the transformer, 0 as the yellow and 230 as the red, that is indeed what we have here. Here's our yellow and our red. So what we're going to want to do now to get the full 120 on both, we're going to have to tie this black wire to this grey wire, and then we're going to take 0 volts as yellow and 240 volts, which is 2 lots of the 120, at the violet. Okay, let's do some soldering. I used a generous dose of flux to make sure I had good connections here, which means I now have to, even though it says, I think it says no mess, no clean it says, which I dispute, because I'm now going to have to clean this flux here. Just make it look worthy of Deizel. Couldn't figure out what CS meant. I think it means common connection or something. And NU are the unused connections. So I guess that, or maybe it means not used as opposed to unused. Beautiful. And while I'm here, I know it's a bit of unusual. Oh, what am I using here? This is what I'm using to remove the flux. Does a good job. Notice there's flux around the tube pins, the tube base pins, I should say. I mean, it's this sort of like, look at how beautifully all these wires to the pots look. Yeah, they've got a bit of slack here, which we like to see. We don't like to see wires tight. Also, if things get changed, you may need that little bit of extra slack in the future. I like that. Attention to detail. So I cut off a couple of these cable ties to just make sure I didn't burn any of the wires. Of course, I don't have any black ones left, so I'm using white ones. Am I 100% sure that I got that wiring right? Because without a schematic, you're sort of doing a fair bit of, well, you're not guesstimating. I'm very confident that I got it right. But to be doubly sure, I'm going to bring it up slowly on the variac. And how do I know if I've reached the right voltage? Well, because plate voltages vary from amp to amp. But there's one thing that's a constant, and that's the filament voltage. So we're going to monitor the filament voltage, and if when we get to 240 volts on my variac, we're seeing 6.3 filament, we know we got our wiring right. I'll be measuring the heater voltage, which is between pins 2 and 7. These are KT77s, actually, not EL34s, as I said before. They can be substituted for each other. KT77 has got higher clean headroom, high plate voltage. I think it's got slightly higher dissipation as well. I think 28 watts, I'm not sure about that. But pin for pin compatible. All right, you can see the current limiter there. I've got it in current limit mode, so we won't ever get to the maximum voltage because of that current limiter. But once I'm satisfied that there's no fault, we'll switch it from limit mode to full supply mode and bypass that. We'll be able to read the current through that little analog meter there. Okay, so with my variac on 0, I was seeing 10 volts already on the plate, and a little bit of something happening there on the filament voltage. Okay, here we go. That's 100 volts AC coming into the transformer. 120. I had some relays clicking then. We've got 3 voltage regulators here on the PCB, I can see. We've got a 7805, which is a +5 regulator, 7812, which is a +12 volt, and a 7912, which is a -12 volt. Might have DC filaments on the preamps, who knows? Okay, we're 190, 200, 240 volts. 240 volts there. Okay. I'm now going to, there doesn't have anything drastically wrong happening. We're not going to see our full voltages until I go in full current mode. So I'm going to dial this down, bypass the limiter, and up we go again slowly. Okay, there go our relays. We're on 180 volts, 370, 4.8. Remember, we're trying to get to around about 6.3. I think we are smack on. We've got 6.33 volts on our filament. That's perfect. 480 volts plate voltage for the KT77s. I reckon it's fine. So we did calculate those wire colours correctly, and I can say we have now safely put this amp into 240 volt mode. But you now know how to figure out what your voltages are going to be, what your wires are going to be, do your impedances between your 0 point and your other wires. Obviously I'm not going to get any reading between this 0 and that brown, for example, so we know we're looking at a different coil. So you can figure it out, and looks like we got it right. All right, now that we're satisfied that our voltages are looking okay, we're going to check the biasing on each of the 4 tubes. So the manufacturers have put a 1 ohm high accuracy resistor from the cathode to the to earth. So this is going to give us the cathode current, which is going to be just slightly higher than the plate current. The cathode current is the plate current, which is what we ideally want, plus the screen grid current. If you want to be really precise, you'd either measure your current going into the tube another way, which I'll tell you about in another video, or you can subtract roughly 8% from the value we're going to read now, Or you can just take it as is, and that's what I'm going to do. If nothing else, it gives you a little bit of safety margin. So here we go. So for this one, because this is a 1 ohm resistor, I'm going to be reading millivolts, and whatever I see in millivolts is going to be directly translated to milliamps. So this one is 26 milliamps, 33 milliamps, 31 milliamps, and 28 milliamps. Okay, they're not properly matched. In a previous life, I may have suggested that we replace a pair of these tubes. In the current pricing, 26 to 34. Divided by 26. It's 30% difference. God, that's pretty high. I don't have any KT77s in stock. I've got enough EL34s, but I'm not going to change it. I'll call the client, the owner, but I'm going to suggest that we leave them in there. Not ideal, but hey, until prices return to some normality, I think this will do. All right, let's have a look and see what sort of dissipation we're getting out of this. Let me check the cold tube. Now, 480 volts on the plate again. 480 volts on the plate. This time we've got 0.0264. So 12.6, divide that by 28. That's 45. That's a bit cold on that weak tube. So we've got one weak tube and the rest of them are just fine. And I spoke to the client and we agreed that we would see if I can set it up so that all of them are in a healthy range. Then he's going to trust my ear to let him know if that one weaker tube is making an audible difference. That's just slightly higher. Plate voltage is now 477. And it's 38, so let's see. 477 by 0.038 divided by 28. 65%. I'm really happy with that. And hopefully this has brought us over 50% on this one. So we got 477 by 0.031 equals 14.7. I think we're there. Divided by 28. 52%, 53%. I am happy with that. That's where the bias is going to stay. And now I just want to plug my guitar through it, see if I can get a good clean sound out of it, and then we'll give it a bit of a sound test. I've fully reassembled it. I've glued down that little flap of vinyl. I'm sure it was glued down in the factory, but when someone pushed the chassis in, as quite often happens, the chassis front catches on the vinyl and just lifts it. So anyway, that's glued down again and carefully pushed back in so it doesn't lift it up again. It's a magnificent amp. It's just beautiful. Have a look at the settings that we'll be doing now for our sound check. I haven't tweaked too much. I've just decided to go with channel 1 for no reason really. So I've got channel 1 selected here. I haven't touched the deep or presence controls at all. My master on channel 1 is, I don't know what you'd call that, about 9 o'clock, about number 2 if there were numbers. I've got the gain up fairly high. It's at about 3 o'clock. And the volume is at noon. I'll show you my recording setup. For the sound check, I record into my Zoom H4n. And I know I've been guilty of clipping sound clips before, so I hope I don't this time. I've got it, as best as I can tell, peaking at about -12, so hopefully I don't clip it again and spoil the sound clip. Then my normal workshop speaker is 70 watts, and I just don't want to risk damaging it. So I've got it going into my 112 orange cabinet, which I just love, beautifully constructed. I made it a bit better, of course, lined it properly. I took out the shitty vintage 30 and put in one of my favourite speakers. That's an Electrovoice EV12LM. It's just a fantastic speaker. It's 150 watts. It can take the whole lot of that on its own. Anyway, let's give it a try. I'm going to be using my German-made Duesenberg, in keeping with our German-made Deizel. Gotta love this guitar, man. I love that sort of almost Art Deco-y sort of look to it. Just beautifully made. It's got a P90 in the neck, humbucker in the bridge. It had a ridiculous sounding middle position, you know, some phasing, blah, 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 pulled all that out. I made it work just like a normal three-way switch where these are both in phase. Sounds great in the middle position now, but I'm just going to be using the humbucker to get a bit of a fatter sound for this. I've got to be honest and say, I don't know many high gain songs, so I will do one of my favourite songs from the 80s era. Awesome! The Deuce through the Deizel. A match made in heaven, Germany, whatever, a match. Beautiful sound. I'm not normally a high gain player, but I got to say that was pretty awesome. I hope you enjoyed it. That's it for this video. Pretty straightforward, but I'm going to see you at the next one. Bye for now.